isolate variables in exponential equations, or how to solve exponential equations. So 8 raised to the x equals 16. So this is the common base method. So what common base fits into 8 and 16? Well, the answer is 2. 2 cubed is 8, and 2 raised to the 4th equals 16. And we gotta plug those numbers in, or replace those numbers, which is called substitution. Okay, so why did I not choose 4? You might ask. Well, 4 times 2 equals 8. That doesn't mean 4 squared is 8, because 4 squared is 16, right? Because 4 times 4 is 16. But 4 raised to something equals 8. How can I figure that out? Do I need to write in another equation or something? No, just do it the easier way. So let's go substitute, okay? Okay. So let's go multiply. 3 times x is 3x. While if you don't know, a raised to the b raised to the c power equals a raised to the bc, or a raised to the b times c. Okay? Which equals 2 raised to the 4th power. When the bases are the same, that means the exponents are equal to each other. So that means 3x is equal to 4. I need to divide both sides by 3 because it's being multiplied by 3. And x is 4/3. To check that, you can plug it in. But I don't want to plug it in because I don't want to make it longer, you know? Why I can plug it on your own, okay? Or just put it on the description, okay? So 8 raised to the x equals 16. This is the logarithm method. So when you take the base, when you take the logarithm of a base number, 2 is the base and then 2 is the argument, 2 raised to the 1st power equals 2. And let's go say, what is log 10? Be aware that the base is 10. So 10 raised to the 1st power equals 10. So let's go do that. So let's go take the log base 8 of both sides. Okay, so there's a property of logarithms. So let's go evaluate log base 8 of 8 raised to the x. You gotta be aware that the property of like this, if it was an exponent, if it's an exponent, then you gotta move it to the other side. Not becoming an exponent, but multiplying it to the logarithm. So this actually equals 2 log x. You gotta remember those. So let's go evaluate log base 8 of 8. So let's go move the x to the front. Okay, so let's go do x log base 8 of 8. We knew that if we take the logarithm of a base, it actually equals 1. So this actually equals x times 1, which equals x. So that's why it equals x. And we're gonna take the log base 8 of 16. I'm gonna fit it over here. I know it's so small. Okay, so these will cancel, giving us x is equal to log base 8 of 16. So the change of base formula. Okay, So log of, let's go say, log base A of B is equal to log B over log A. So basically, the logarithm of an argument divided by the logarithm of the base. And you can change to like, and it has a new base, which is C. Well, we're gonna use that in this equation using the logarithm method. So let's go convert it into change of base. Well, you can still, I'm gonna do it like this. It's simpler for a base of 10 for me. Whatever works fine for you, it's fine. Now, what is the common basis of 16 and 8? The common basis of 16 and 8 is 2. So we're not looking for 16 divided by 8. So we're actually looking for the common basis between 16 and 8, which is 2. So we can write 16 as 2 raised to the 4th power, and we can write 8 as 2 cubed. Now remember, we can move those exponents to the front, giving us 4 log 2 over 3 log 2. Now, if you look closely, log 2 divided by log 2 actually equals 1. So giving us 4/3 times 1, which equals 4/3. So that means x is 4/3. Now, then what about taking the xth root of both sides? It might sound confusing, but I would not recommend doing this. It's gonna make it longer. This is the steps, but I would not recommend doing it. If this best suits for you, then go for it. So when you take a square root of a square, it actually cancels. So when you take the x root of x, the exponent x, the x's cancel, while 8 raised to the x over x equals 1. So that means 8 raised to the first power equals 8. So this actually equals 8 equals the xth root of 16. We gotta convert the hold on. We gotta find common bases. I'm pretty sure. We gotta find common bases. So to make the okay. So let's go convert 16 into fractional exponent, okay? So 8 is equal to 16. By the way, there's a 1 over here, just to make sure, if you're wondering. So 8 is equal to 16 raised to 1 over x. So 8 it is 2 cubed, right? And then 16 is 2 raised to the 4th power. Now, you gotta write parentheses and then 1 over x. Remember, we gotta multiply the exponents. So 2 cubed is equal to 4 times 1 over x is actually 4 over x. Okay? So 2 raised to the 4 over x. Now, we can make the exponents equal to each other since we've multiplied and the bases are the same. So 3 is equal to 4x. Now, to isolate the x, I need to multiply x. I need to get rid of the fraction. So x times 3 is 3x. Now, if you multiply a number by its reciprocal, like 1 over 2 times 2 over 1, or 2, did this actually equals to 1. When you multiply by its reciprocal, it actually equals 1. So that's how it works. So 1 over x times x is actually 1. So this gonna actually turns into 3x equals 4. And then when we divide both sides by 3, x is 4/3. So I would recommend doing the logarithm and common base method and then taking the x root of both sides. Because the x root of both sides, or the variable root of both sides, is actually more steps. So that's why. Bye guys! I would probably make the second part. I would probably make more problems in the future, okay? Bye.